Hello and welcome to the CET's Data Space workshop Extending Pyrus. The knowledge acquired here can be used, among other things, to extend Pyrus with new features and domain knowledge. For this purpose, extension mechanisms of Pyrus based on Jupyter Hub is explained. This workshop is primarily intended for people who have knowledge of Python programming. In addition, the other workshops on Pyrus should have been completed. For the use of the dataspace Pyrus and Jupyter Hub, accounts are required, which can be requested from the CET staff. To understand the extension of Pyrus, it is first necessary to explain how Pyrus and Jupyter Hub work together. For this, the system architecture is explained. Now a new library will be implemented which provides Python functions. This library will be implemented in Jupyter Hub and then propagated to Pyrus via synchronization. Finally, it is shown how the no-code models based on the new library on the Jupyter Hub are executed. The system architecture first shows the two components, Pyrus to the left and the Jupyter Hub to the right. At this point, the process of how Pyrus can use and execute the libraries stored in Jupyter Hub is described. First, the Jupyter Hub REST API is used to load and search all existing Python files of the connected user to find the published functions. These functions are collected and then available for modeling in Pyrus. The execution of a model is done in several steps. First, the data flow process is translated into a control flow process, as an imperative programming language like Python is to be generated. This so-called base process can then be transformed to Python code. The generated code is in turn sent to the Jupyter Hub, which executes it and returns all the result the code generates. These results are collected in Pyrus and displayed in combination. Now we will show how to create a new library. First, a Python file must be created. To do this, the file system is opened via File and Open. Afterwards, a text file can be created over the New button on the right side. The text file must now be renamed to the library name and the .py format. At this point, any Python function can be defined. Here at the example of arithmetic function to sum up and subtract two numbers. As in any Python file, of course, other or external libraries such as pandas or the like can be included. To publish a Python function so that it can be recognized by Pyrus, it must be annotated. First, the function name must always be specified. For this, a comment is introduced by a hash, followed by an empty line and the keyword method : Now follows the function name, which must match the Python function name. Next, the data inputs must be defined, which correspond to the Python function arguments. Each function must have at least one argument, i.e. also a data input, in order to be reached in the data flow process. The individual inputs are described as a pair of name and type, separated by a colon. The names do not have to match the actual Python arguments, but the order does. If multiple inputs are to be defined, the pairs are separated from each other with commas and spaces. Finally, an optional output can be defined, specifying what the function returns. If nothing is returned, the outputs line should be omitted completely. In case something is returned, a pair of name and type must be specified here as well. There can be only one or no output at a time. The individual types can be chosen by the user and thus from a static type system which is validated by Pyrus at modeling time. Each type is thus only symbolically considered and validated, which means that an output can only be connected to an input if the type name matches exactly. Concepts from object-oriented programming like polymorphism, abstraction and inheritance do not apply here. Now that a new function is available in the Jupyter Hub, it has to be found by Pyrus. To do this, the synchronized function service is called in an already connected project, which searches for the functions and propagates it. Afterwards, the echo area can be updated and should list the new function. This function can now be used to create new data flow processes. For this, the new function is dragged onto the canvas and shows the inputs and outputs defined by the annotation. Also, you can see that the described types have been taken over and are now used for validation. After the model is complete, it can be executed using the code generation steps described earlier. The model was extended by numerical constants describing the incoming data. At this point, it should be said that the constants are not validated against the inputs. Depending on the type of constant, only the correct syntax is generated, like the quotation marks for the text constant. Afterwards, the model can be executed as usual via right-click Execute on Jupyter. In the background, the data flow process is now converted into a control flow process and subsequently translated into code, which can be seen here on the right. The results of the execution are finally displayed in Pyrus. I hope you were able to follow all the examples and get an insight into the use of Pyrus and Jupyter Hub. It was shown how Pyrus and Jupyter are connected to realize an extendable and flexible modeling environment. Pyrus can be extended by a new Python function implemented on the Jupyter Hub and annotated to be exposed. The different requirements of the annotation have been explained and demonstrated. Afterwards, a walkthrough was given to show the different single steps to create a new library. Last, the execution by code generation has been explained. Thanks for participating, and I hope to see you soon in the data space of the CET